Okay, last one. We're going to use trigonometric substitution, and this is listed as a calculus skill in our pre-calculus book, so we want to make sure that we know how to do this. This is something you might run across next year. It says use the substitution x equals 2 tangent theta, and it tells us here that theta must be between 0 and pi over 2. Really, all that's doing is telling us it's between 0 and 90 degrees, which is telling us first quadrant. That's all this information states here. So use the substitution for a triangle in the first quadrant to rewrite this 4 plus x squared as a function of theta. So in other words, right now, I have 4 plus x squared, that's as a function of x. I want to write it as a function of theta instead. I'm going to show you two ways to do this. I'm going to show you what it really means. And then down here in the second example, I'm going to show you the quick way to do it. So really what they're saying is, if I was to draw a triangle between 0 and pi over 2, if I was going to draw a triangle up here in the first quadrant, what I know is that x is equal to 2 tangent theta. And if I rearrange that, then I could say that tangent theta is the same thing as x over 2. That's the ratio, which means that the opposite side must be an x and the adjacent side must be a 2. Opposite must be x and adjacent must be 2. Now, once I get these two sides, I could probably solve for the hypotenuse. What I know is that the hypotenuse can be found using Pythagorean theorem. X squared plus 2 squared has got to be h squared, h for hypotenuse. That means that x squared plus 4 is the same thing as h squared, which means that h must be the square root of both of those sides. H must be the square root of x squared plus 4. Not a coincidence that it ends up being the same thing as what they give us. So I'm going to go ahead and rewrite it up here as 4 plus x squared. I got the square root of that. So here's this angle, theta. This is what I've got so far. I've got a triangle here in the first quadrant because it's between 0 and pi over 2. It's got an opposite of x and adjacent of 2, and that means the hypotenuse is the 4 plus x squared. And so if I want to write the hypotenuse as a function of theta instead, what I know is this. So I don't want to involve the x at all. Okay? If I want to write the hypotenuse as a function of theta, here's what I know. I know that the cosine of theta is equal to 2 adjacent over hypotenuse square root of 4 plus x squared. Now if I multiply both sides here by the 4 plus x squared, I see that on the right side they cancel out. On the left side I get 4 plus x squared and the cosine of theta. But this is what I want to get by itself. I want to write this as a function of theta. So far I have this. 4 plus x squared, square root of that, cosine theta is equal to 2. I'm going to divide both sides here by cosine theta. Those go away, and I'm left with this. The square root of 4 plus x squared must be equal to 2 over the cosine of theta, which we can write as 2 secant theta. In other words, what I've done now is I'm saying that, let's write out the final answer. What I'm saying is if I'm writing this as an expression in terms of the function of theta, I'm saying this is equal to something, and the only variable that I have over in this something is theta. There's no x over here, right? So there's my answer. It's 2 secant theta. Seems like a long process, right? Well, there's an easier way. And it turns out is the reason they tell us to use the substitution is because really what they want us to do in this problem. Now that's the long idea. That's what we're trying to get at. But what I can do then is if I know that x is equal to 5 sine theta, then really I can just plug it in right here. Here's the fast way to do it. So, with that in mind, instead of writing 25 minus x squared, let's write 25 minus 5 sine theta squared. Oops, squared. Don't forget the square. Now if I square that term, that turns out to be 25 minus 25 sine squared of theta. I can square both the 5 and the sine. Now I see here that I've got a 25 in both terms, so I'm going to go ahead and pull that out. It's 25 times 1 minus sine squared of theta. I just factored out the 25 on the inside, and the reason I did that is because I know the square root of 25, don't I? Isn't that just 5? So really I have 5 times 1 minus the sine squared of theta. But then, the last step, and this is pretty convenient as well, is that I know that sine squared theta plus cosine squared theta is equal to 1. And so if I move this sine squared over, subtract it from both sides, I can create a situation in which I can replace 1 minus sine squared of theta, I can replace that with cosine squared of theta. Why is that convenient? Because I have the square root of a square. Square roots and squares cancel each other out. That means this just leaves me with 5 times the cosine of theta. And if you'll notice, I get kind of an answer in the same format as what I did above. We could have done this a lot quicker in the first problem, couldn't we? So, using the trigonometric substitution, I have now written square root of 25 minus x squared. Instead of that, I'm going to write the hypotenuse as 5 cosine theta. In other words, up here in this problem, I could have drawn a triangle and I could have said this is x, this is 2, sure, but this is 2 secant theta. And that would have been a much easier way maybe to write the hypotenuse. And that's the idea.